I am starting the recording now, and I am recording. Welcome to our Routing Switching Essentials ITC course. One thing I want to make you aware of, I am behind grading. I was at a conference all week last week, so I was at the NCCIA conference, had a good time, met with a lot of colleagues and a lot of folks, so that was very good. Presented 3 different times, that was also good. So I am behind grading. I would like to make a couple of announcements. One is next week I will be here Monday. I know it's Easter Monday, and I really am going to leave it up to you. Honestly, I'm not going to have class. I won't have class next week. We'll call it a spring break week and a catch-up week for all classes. So you don't have to worry about trying to be in class on Monday, because I know most of you are probably off. Keisha and Corey, you're both off on Monday, aren't you?
I'm off on Friday.
Friday, okay. Well, I'm supposed to be off Monday, but I'll actually be here with our data center folks as they're actually drilling holes. So we'll be drilling holes on Monday. But what I want to do, I want to show you a couple things. First off, I am going to share my desktop. And I want to show you on the Cisco site, something that I just discovered again. I know I showed you last week about the looking at the exam objectives, but you'd be amazed as I'm looking more and more at these things, what I'm learning. So let's look here. Someone's going to take the CCENT exam. So we click on CCENT. We obviously can look at the objectives for all those things. We also can look here at the Learning Network Resources ICND1 study materials. And when you click here, some of it is for pay, obviously, okay? But then there's a large number of items that are free. So let's say you want to look at IPv6. Well, here's an IPv6 thing that you can actually watch right now. And here's an IPv6 request. It goes out to the Learning Network. You'd have to log in. And then once you log into the Learning Network, you can watch this video. Be aware that access to the Learning Network is free. So all you have to do is request an account, and you will be able to do that. So I thought that was pretty cool. How I'm having some trouble. Actually, I got pop-up blocked, so that's why it's not working. But that will work in a different browser. But you look inside of here, there's all different types of things that are available under these study materials. IP addressing guide, if you want LAN switching, for instance, if you want to know more about securing LAN switches or managing MAC address tables, all right? And if it doesn't have a little pay item beside it, it's free. So kind of nice that you can go through here and do these things without having to pay for it. Now, if you wanted to pay, you could, but you don't have to. A lot of these things are free and available for you to download and look at. So, overview and preparation. So, collection of live seminars on all types of stuff, which is really neat. Foundational network skills, exam topics, all the way down through. And this exists for both the CCENT and it does actually exist for the CCNA. So, if you go to CCNA routing and switching, you will see the study items for the second test. So ICND2, if you click here, it will take you and you can find study materials. Okay, well, I actually went to the wrong place. You go here and you look at study materials, CCNA study materials, and then you can see items that will allow you for the 125. So any questions on that? Because I thought it was pretty cool to be able to see that. I really found that when I was looking for myself at certifications, and looking at the CCNA CyberOps, and looking at a large number of items they had for study materials for the exam. So for SecFund, they had all type of stuff, and then for SecOps, they had all types of stuff. So good little thing here to join Cisco Learning Network and have access to these items. Okay.
And where do you get access to that?
You can just go Cisco Learning Network, and then make yourself, you can basically take your Cisco account. If you already have a CCO account, you should be able to get on the Cisco Learning Network by default. It'll just ask you to log back in with your Cisco account, and you'll be able to do that. Okay. Quick reference guide prepared for CCIA. So, like I said, just Google Cisco Learning Network, and if you already have an existing CCO account, it will take you directly in there to it. Okay? Other questions about that?
So our Metacad doesn't get it?
No, Netacad does not directly integrate with that. No. It is a separate, that's a separate item, the Cisco Learning Network. It is Cisco's site where they try to sell you training, but it's also a learning space that gives you access to a large amount of information. Let me sign out. Let me sign out of here and see if I can't. I have no point. Log out and try to show you just the front page of it. So you can see how when you go to the home for the Cisco Learning Network, it looks the same, but if you log in, it would just be logging in with your CCO account. And then you can look up different certifications, different information, and some of the items you can actually get without being logged in, but the majority of them, when you go to like study materials and things, you go to click on something, it's going to ask you to log in, and some of it doesn't. You'll notice I'm not even logged in, and it went in and started talking about CVSS, and here's an entire section on that. So there's all kind of links that I can use, file times, looking at MSDN file times, so it takes you out to a link that's based on that. So pretty cool stuff, really. And all that was without even logging in, so you can just Google the Learning Network, Cisco Learning Network. Any other questions? All right, let's talk about VLANs. Now, VLANs or virtual LANs are a way of taking a switch and logically separating it. So imagine if you did have this switch in this particular situation here. You had IT department members on each of the 3 floors and HR and sales members, and you wanted to separate their traffic. But you also, at the same time, did not want to buy separate switches for each one of those groups. The way to do this is to create VLANs, and those VLANs can be created on a per port basis, and then you would plug each one of these PCs into a different port, and then those ports would be assigned to a VLAN, and then for all practical purposes, it's like putting them into individual switches and individual collision and broadcast domains. So you don't have traffic between VLANs even impacting one another because they don't see one another. VLANs require a router to go between them, so they are different subnets. So that's one thing that virtual local area networks, and one of the things I want you to also really get in your head is that a VLAN equals a network, and this is a layer 3 network, okay? Because each different VLAN, in this case, you'll even see it in our example here. The IT VLAN is 10.2, the HR is 10.02, the HR is 10.03, and the sales is 10.04. So they are different layer 3 networks or subnets. It could be subnets too, but it's a layer 3 network.
So everything that's sent from one VLAN goes out the switch that it's connected to, sent to the router, and routed back to another device on that same VLAN.
Exactly. Exactly.
Okay. That makes perfect sense, because that was the one question that I had for you, because I noticed that they're all different subnets, and I wasn't sure whether the switch was routing or whether they went through the
well,
router.
the switch is not routing.
Right.
The switch is tagging traffic, okay? And we're going to learn about 2 different types of ports. We're going to learn about a port called an access port, and we're going to learn about trunk ports, okay? And trunk ports can carry what is called tagged traffic, and that's traffic that has been tagged with VLAN tags. An access port cannot carry tagged traffic. In other words, you put your switches are connected together with trunk ports, but when you connect your PCs to the switch, you typically connect them with access ports. And we'll talk more about that as this class continues on, okay?
Well, a couple of the examples that they started out with didn't have routers in them in the book.
Right, right. Yeah, and that's
what was throwing me off.
And the problem with that is, and in fact, I think there's a packet tracer that has you and a lab that has you doing VLANs with no router. And what you learn, and the reason they do that is because they want you to realize If there's no router in the mix, you cannot go between the two separate VLANs.
Okay.
That's really what they're trying. The lab's actually designed to do that. While I will tell you this, it is a little bit confusing. Because you look at this, if this was a network that you had created, you'll see that each one of these ports is assigned to a different VLAN. Then these F0, 11, 18, and 6 would all be access ports, okay, because that traffic would not be tagged. And then this link between these two switches would be between FA01 and 01. This would be a trunk. This would be a trunk here, 03 to 03, and 01 to 05 would also be a trunk up to the router. And we'll learn about routers on a stick and trunking and those things. We'll learn how that happens. But basically, what would occur is if you did have traffic going between two VLANs, it would go across F011 over 01, up to R1, be routed back to, let's say, VLAN 20. Now, if that traffic was going directly to VLAN 10 on the opposite side, from VLAN 10 on the left side, it actually would not have to go to the router. It could just go through the switches, because the switches maintain this trunking and have the information about those VLANs. So to move from VLAN to VLAN across switches, you don't, if it's the same VLAN number, the same VLAN tag, you do not have to have a router. It's only when you move between VLANs that you need a router, because remember, VLANs equals subnets or networks. Now, what are some of the benefits? Security. Faculty do not want students on their VLAN. Makes sense to me, okay? Cost reduction. Now, I will tell you this. There are ways to do what's called VLAN hopping, multi-tagging, stuff like that. That's a pretty advanced technique. It's possible, but it's pretty advanced, and you're doing some guesswork to try to get to the other side. But VLANs are not an absolute guarantee of security. They just make things a whole lot harder for hackers. The other thing is cost reduction. Instead of having a faculty, student, and guest switch, by one switch it's got 24 ports, and then assign the ports to the VLANs as needed, or more ports. You can do 48 or 96, whatever you want to do. Better performance, because you don't have a flat layer 2 network with all of the devices broadcasting on them. Remember that when you create a VLAN, you're also creating a broadcast domain, because the VLAN is a network. So that VLANs reduce the size of broadcast domains. Because if we had this network with no VLANs, it'd be one big broadcast domain. We've actually got a VLAN 10 broadcast domain, a VLAN 20 broadcast, and a VLAN 30 broadcast domain. Now, the staff efficiency, not really sure about that one, but it can make it somewhat easier to manage. And the biggest thing is it allows you to design your network and use your network the way you want to use it. Now, what are types of VLANs? One is a data VLAN, and that is one that carries user-generated traffic. By default, as I've told you in the past, all ports are in VLAN 1, which makes VLAN 1 a bit of a security risk. You really don't want to use it for data traffic or management traffic, because you don't want someone to be able to just come in and plug into a port and that port go active, and then they're on your VLAN 1, which could be, a data or a management VLAN. Having said that, hopefully you've learned in Chapter 5 how to do port security, because that's one of those configure things that's on the exam objective. And so you could use port security, which would help, but it's still a best practice to move all of your ports off of VLAN 1 or out of VLAN 1 into a black hole VLAN, which can just be a VLAN that you're not using, like VLAN 555 or 777 or whatever. And then you can put all your ports out there and then move them to the correct VLAN as you want to do that. Just remember, the default VLAN is in fact VLAN 1. Okay. Now, Keisha, this is where things are a little bit funky. Let me take you to the picture, and we'll help a little bit, not a lot, a little bit. Let me find there's one out here where they've got a native VLAN. Okay. Now, I told you that trunk links carry tag traffic. And we're going to talk about what a tag is in just a second. But basically, tag traffic is a frame that has had a .1Q tag placed into it. That tag causes the frame to be bigger than the default size. So if you're not using a trunk port, that will be seen as a damaged frame and it will be kicked out. In the old days, and because it is Ethernet, you could not guarantee that a link, even a trunk link between two switches, didn't have a hub on it. All right? So they had to do this native VLAN, and all it means is this. The native VLAN on a trunk link is untagged. That's all it means. Why is it there? Just because of old legacy technologies like this. So, what do? The typical thing that I've seen for security wise is when we set up a trunk port, set the native VLAN to something that is not in use on either, at all. So if you've got VLAN 100 not in use anywhere, set both sides of the trunk link to native 100. That way the only traffic that's untagged is no traffic. So you don't have to worry about it. And then you tag everything else. Again, it's not that big a deal. It's one of those things that drives people crazy. But all it means is that when you have a native VLAN, it is the traffic that is untagged on a trunk link. Does that make sense, Keisha? I'm going to pull my chat out. Did you drop off, Keisha? Are you here? Hello? Hello?
Kelly.
Yes.
Do those frames get dropped?
Well, here's the problem. If no, they do not. Okay? As long as you make both sides the same native VLAN.
Okay.
So in other words, imagine this, and I'm gonna go ahead and jump forward just a second. I'm gonna jump forward to this picture right here. Okay. So let's assume that we made native VLAN, and I know I'm telling you I'm breaking the rules here, but Keisha, I cannot hear you. You're typing, so I can't hear you talking. So I don't know what's happened there. But let's imagine that I made native VLAN 99 on port F01, but I forgot to change it on port 011. What would the native VLAN be on S2 since I didn't change it?
Shouldn't the one from S1 force the other one from S2? Did I read that correctly?
Right. S2 would be on native VLAN 1. S2 is native VLAN 1 on this port. S1 would be native VLAN 99.
Okay.
You're going to get a mismatch because one side is untagging VLAN 99. The other side is untagging VLAN 1.
Okay.
So the end result is those two sets, 1 and 99, and actually you'll get a message that says mismatch native VLAN. But both traffic from 99 and 1 would be unable to move across this link because it's being tagged on one end and it's expected to be untagged on the other end. So the answer to your question, Corey, is it will be dropped if both sides are not set to the correct native VLAN.
Okay, that makes sense.
If both sides are set to the correct native VLAN, it will be sent, but it will be sent untagged. And it says, is a native VLAN necessary requiring a VLAN switched environment? Yes. And the reason that is, Keisha, again, is it's just to support legacy technology. And also by default, all trunk links are native VLAN 1 by default. So you have to set it or leave it set to native VLAN 1. Security best practice, again, is to set it to a non-used VLAN for that native VLAN. Okay. Another thing here is a voice VLAN. They don't do a whole lot with this, but it is something that can take place. Using CDP and in some cases LLDP, depending on the phone. The phone can actually create a trunk back to the switch and then allow the PC's traffic to come across. In other words, VLAN 20 is the data VLAN, whereas VLAN 150 is voice. And so it would, for the most, what it will actually end up doing here is it will be able to trunk two different VLANs by tagging the data with VLAN 20 and the voice with VLAN 150. and that's because the phone can create its own trunk automatically using CDP. All right. A little weird, something we don't cover a lot in this class, but it's there.
So
okay.
with that,
yep.
The phone tags the data from the PC with VLAN 20.
Correct.
And to VLAN 20, the tag is going across that trunk between S3 and the phone.
Correct.
But
basically, what it is, the IP phones have a built-in switch in them.
Right.
And they just build a trunk link with the switch they're connected to, and then they tag the data traffic and they tag the VLAN traffic or the voice traffic. And they tag them with the different VLANs that are necessary. And you configure this by doing a set of commands on the switch that tells on this trunk port which one's the VLAN and which one's the voice VLAN and which one's the data VLAN.
But they're still going across tagged with the different VLANs.
Correct.
Frames.
Correct.
So if a device was directly connected to that port, bypassing the phone, that was still assigned to VLAN 20, it would still work.
Correct. It would, the phone, yes, this port is actually, technically the way it works is this port is assigned to VLAN 20, and then it's got voice VLAN 150, and then the phone can tag the traffic based upon that information.
Okay, so if the frame isn't generated by the phone itself, then it's going to tag it with...
Correct. It's going to be tagged with VLAN 20, correct.
Okay, so configuring a data VLAN and a voice VLAN are two different commands on the actual switch itself.
Correct. Yes.
Okay,
you'd have to build both the voice VLAN and the data VLAN, and you would have to tell the switch that it's going to be supporting both.
Okay.
Yep. Trunks. Now, again, trunks are any link that can carry tagged traffic. And that is what is needed. This is one of the labs you do here. Obviously, you will not be able to ping between VLAN 10 and VLAN 20 in this scenario because there are no routers. All right? But you can ping between 172.17.10.21 and 10.24 if these trunks are up and working correctly. Now, what happens is, and this is something very interesting to note, as the frame comes in on FA011, it does not get tagged until it comes into the switch. Once it is tagged on the switch with VLAN 10, that's a .1Q tag. If trunking is working correctly, it would be allowed to cross this trunk tag as long as VLAN 10 was not the native VLAN. It would then come back over here, and then if it was destined for the 10.24 IP address, when it leaves this switch 3, the tag is removed. Otherwise, the PC would see the frame as being too big. It'd be like a jumbo frame, and it would consider it to be damaged. Now, one thing that's important to note is there are actual NICs this day and age that you can trunk through. And that happens a lot in our virtualized environments where we're sticking servers off of a switch, and that server has multiple VMs, and those VMs need to appear on multiple VLANs. That's what they're talking about here, talking about NICs that can support, .1Q NICs. Okay, so that's an interesting thing just to kind of throw out there. Notice with broadcast, if there are no VLANs, even though they're on the same network, when you send a broadcast, everybody sees it, including the students, so that would be a bad thing. As soon as you put in VLANs, only those hosts associated with VLAN 10 will see the broadcast, because as the traffic comes in again, it's tagged with VLAN 10, and it would only be sent to any ports that are configured to be in VLAN VLAN twin. 10, that is. So here's .1Q. You can see that you've got a frame, destination MAC, source MAC, and then a tag. And that tag goes in. It's got the VLAN ID, which is 12 bits, and it's called 8021Q. But we most of the time we just call it .1Q. So we just take it and say, hey, instead of 8021Q, we say .1Q. And when you use that command, encapsulation .1Q, that means you're using 8021Q tagging. There was an old method called ISL, interswitch link, which is not really supported by Cisco devices anymore. But if you see older Cisco documentation and you see ISL, ISL is simply another method of tagging. So you'll notice since the VLAN ID is 12 bits, it is a maximum of 4096 VLANs. And you can see that, you know, the canonical format indicator was for token ring, and then priority bits, that can be DCSP and other things there, and then values. And for most of the time, since we're all going to be running Ethernet, it'll be set to 0 by 8100. In fact, okay, you could be running other stuff, but you're probably going to be running Ethernet. And for the purpose of this class, you're going to be running Ethernet, so 0 by 8100. Now, again, here's the big thing. Native VLANs are not tagged. So when you create a trunk and it asks you for a native VLAN, which is by default the VLAN 1, okay, that just means that any traffic going across the trunk is not tagged as it crosses that trunk. You have to have it set to the same on both sides, otherwise it will get in trouble. And that is just supported so that you can support legacy equipment or some type of item like this, where you put a hub in here and you have a PC trying to get on this. If you have a PC sitting on a hub on your trunk links between switches, you have designed your network incorrectly. So here we have the voice VLAN. You see the switch port instructs phone to tag voice frames with 150 and gives priority to the voice frames and forwards data frames for VLAN 20. And it's configured to tag it with frames 150. That's what this 3-port switch does here. This is an access port. This is a trunking port. And you can see how we do it here. Basically, it shows you that it's access mode VLAN is 20 and the voice VLAN is 150. And you don't do a whole lot of this in the class, but there's some sample output just to show what it is. And then they say it's beyond the scope of this class, so these are not the droids you're looking for. Move along. Just be aware of this, that the phone does have a little switch in it, and it will tag voice frames and then pass data frames. All right, VLAN ranges. We've got normal VLAN ranges, which are basically 1 to 1005. And then you can do extended VLAN ranges depending upon, and that's anything from 1006, so actually it's above these normal ranges, to 4094. All right, sorry folks, I clicked on the wrong thing. By default, VLANs are stored in running configuration. They're also stored in the VLAN.dat file on a switch. And I showed that to you when we were creating VLANs the other day, how when you create a VLAN, until you actually exit from the configuration on a real device, the VLAN does not get created. I think I showed that in my scaling class, not in your class, sorry. I'll show it to you. Now, here's the thing that you've got to understand. With VLANs, it's a two-step process. One, you need to create the VLAN on the switch. And then two, you need to put ports in the correct VLANs. All right, so just creating a VLAN will not do anything for you. You've got to actually put the ports into the VLAN. Give me 1 second, folks. I'm going to bounce out here. I should have had this done. I apologize. Man, I got people doing all kind of work. This is good to see. Have y'all had any trouble with NetLabs? Any issues at all?
Well, other than the fact that some of the questions on the exams won't populate, no problems.
Okay, if you run the PTSA, Packet Tracer Skills Assessment Checker, while this thing's booting up, let me show that to you real quick. If you are in NetAcad, and that, by the way, the NetLabs is different than what you're talking about. You're talking about the actual class itself. But if you're in the class under Student Resources, there's the Perform Packet Tracer Skills Assessment Environment Checker.
Mm-hmm.
Keep that and then actually run it. And then it should go through and tell you whether or not your machine supports what is needed to run the skills assessment. So what's happening is you're taking exams, and those exams are trying to go out and open Packet Tracer, and Packet Tracer is not opening. And then this will actually go through and see whether or not your system is designed or ready to do that in your browser. And you see mine says it is. So.
Well, some of the some of the quizzes have the same thing, and I don't have any problem with that.
Huh.
It's not the Packet Tracer ones, it's the Flash ones that I have problems with.
Oh, okay. Okay.
Yeah, the Packet Tracer ones will populate.
Okay. Well, the only thing I can tell you about that is they are working to get Flash out of the curriculum. It's just going to be 2019 before they do it, which is bad. But you know how embedded it is in the curriculum.
Yeah.
So we go to create a VLAN. We do VLAN, the VLAN ID, so that's the number. Then we give it a name. And then, very simply, here we're putting in the VLANs. And then we have to assign the port to the VLAN. So until you assign a port to the VLAN, it's really not doing anything for you. Okay. Here we're looking at making this an access mode port, which means it's not going to carry tag traffic. And switch port access VLAN 20 means any traffic coming in this port will be tagged as being part of VLAN 20. So to have a .1Q tag identifying it as part of VLAN 20. Sample topology with the phone. Here we have the phone. We do VLAN 20 name student, VLAN 150 name voice. You do switch port mode access, switch port access VLAN 20. And then you put in your quality of service, then you switch port voice VLAN 150. And you'll know that the traffic for 150 is going to be tagged and the traffic for 20 will be passed. So anything that's untagged should be for VLAN 20. Anything tagged should be for VLAN 150 and will be sent accordingly. Now, how do you move ports? Well, you can do no switch port VLAN, no switch port access VLAN, then the number, or just no switch port access VLAN. Now, what happens is that doesn't actually remove it from all VLANs. It drops it back to the default VLAN, which is what?
VLAN 1.
VLAN 1, correct. So VLAN 1 will be dropped back. Will be dropped back to VLAN 1 and you're able to do that. Still booting, so I'll come back to it in just a second, show it to you. So here we see we created the VLAN, but nothing's in it. You'll be amazed the number of times I've had students do this and say, I don't know why it's not working. Well, because you don't have the ports in the VLAN. Once you put them in the correct VLANs, they will show up as being as part of that VLAN when you do a show VLAN. This is show VLAN brief, but you can also do show VLAN. Okay. You don't want a VLAN, do no VLAN 20, but I will tell you the first thing you need to do is move all the ports out of that VLAN first. If you don't, you're going to end up orphaning those VLANs. And so you don't want to do that at all. Otherwise, you end up with a real mess. You've got your ports out there, and they actually will go to an air disabled state. They'll go, well, not air disabled, but they'll go into a amber state because they are not able to find their VLAN. So what I'm going to do is pull this over here. So this is the switch, and I'm going to show you the diagram here. It's our diagram. So what I'm going to do is I'm going to actually create on switch 1 first. I'm going to do enable, and I'm going to do config T. I'm going to do a host name S1. And then I'm going to do line con 0 logging synchronous so I don't mess myself up. I'm going to type exit. Now what I'm going to do is I'm going to actually assign this. I'm going to create VLAN 10 and I'm going to create VLAN, I only had to create VLAN 20, I'm going to create VLAN 10. So let's go in there, we'll name it student. So I'm going to go VLAN 10, name student, capital student. Now I want to show you something. If you do a do show VLAN right now, that VLAN does not exist. If you do this same thing in Packet Tracer, it will automatically put this VLAN in here and it will make it look like the VLAN has been created. The problem is, it hasn't been yet. In fact, if I do a do dir, you should see there's not even a VLAN.dat yet. So there's no VLAN.dat. All right. I got to go in here and clean these things up. Somebody's got so many different little things in here they've got saved. Now I'll actually fix that in just a minute. But if I type exit or in, let's type exit to move back one level. Now if I do a do show VLAN, you're going to see VLAN 10 in student. You're also going to see, if I do a do dir, you will see a VLAN.dat down at the bottom. That is a major difference between Packet Tracer and real switches. You'd be amazed the number of times I've had people do this. I'm just going to put in another VLAN. VLAN 99, name management, okay? And then they go do show VLAN, and it confuses them because that VLAN doesn't show up. But until you exit config VLAN, it is not written into the VLAN.dat file, and it does not show up. Does that make sense?
Yes.
Big issue. Have you seen that before, anybody?
No.
By the way, if you ever need to delete stuff that's inside of here, see how somebody put star at? Just do del flash colon STARAT. Just make sure you actually say that name. Don't delete your flash. If you do that, things go very, very bad for you. Because then you delete the whole switch. So, but you can delete individual items out of flash. And then now I can do a dir, and you'll see those last two items in there are gone. Okay. That's also how you delete the VLAN.dat. If you ever want to get rid of your VLANs, you know, if I do a show run right now, you will see that I've got the VLANs in here down at the bottom. Okay. Say interface, well not here, but if I had my ports in it, you'd see the VLANs. But you'll see when I do a dir or show VLAN, I've got my VLANs. Okay. What I need to do now is I need to put port 06 in that VLAN. So I go to config T, int FA06, switch port mode access, because I want an access port. Switch port access. Oops, I didn't mean to put capital. Access. Access. VLAN 10. Now if I do a do show VLAN, 06 is in the VLAN. Okay? So, now that port, student 10, is in VLAN 10. Or PCA is in VLAN 10. Now I'm going to go over to switch 2 real quick, and I'm going to actually pop it up and just real quickly do the same. I'm not going to change the color on this one. I'm just going to do it real quick. Config T. Any questions about the commands I'm doing for this?
No. Can you hear me?
Oh yeah, gotcha now.
Okay, I had to restart. I'm sorry. No comment.
So that the fact that the VLANs did not show up did throw you off, Keisha?
Yes, when we were practicing on the real equipment and Packet Tracer, and I had to remember.
Yep.
Okay, go ahead.
Yeah, that to me is a big issue with Packet Tracer because it is different, which is you know, not good. All right, so I got that VLAN. I'm going to go int FA011. I'm going to do switch port mode access. Switch port access VLAN 10. All right, so now what I should be able to do is put these two PCs in the same VLAN, the same network. So let's go in here and just real quickly. And Sorry, y'all. Brain fart. Network and sharing. Now, I know there's different IP addresses used in the lab, but I'm just going to use the ones I'm going to use because I like them. 192.168.12.10. And I'm not going to put a default gateway in because there's no need, because there's no router in here. And then I'll go to PCB and put 12.11. Control panel. I'm going to go in here and put 12.11. Why did I not have to issue the no shutdown command on the switch ports?
They're already enabled by default?
Correct. By default, all ports on the switch are turned on, unlike the ports on the router, which can be a security issue. So let's see here. Now I'm going to do an IP config, and you'll see that I've got 192.168.12.11. So I'm going to ping 192.168.12.10. Huh. Destination host unreachable. Let me go back. Okay, so let's go here. Ping 192.168.12.11, which should be the other side. What's going on, folks? By the way, I did this on purpose.
Oh, I was going to say, did you put?
No, I did this on purpose. There's a reason.
There's the trunk isn't configured.
Correct. In other words, traffic coming in from PCA is going in here and being tagged with VLAN 10. But this link across between S1 and S2 is not a trunk link. And so it's not able to carry tagged traffic. So what we've got to do now is we've got to go back to S1, okay? And I'm going to go to interface FA01, and I'm going to make it easy. I'm going to say switch port mode trunk, all right? And then we'll go back to S2, and on S2 I'm going to go to int FA01, and I'm going to switch port mode trunk. And then now I'll go back over here so you can see it better. Do show int trunk, and you should see I now have a trunk. And you'll notice, look what's native. One is native by default. Now watch what happens. It'll probably fail the first 1 or 2 times and then start working, hopefully. I've done it right. If not, I could have a problem. There it goes.
Now, when you did that before, between the 2 switches, those frames were dropped because they were larger than the maximum size, correct?
Exactly, exactly. They could not pass across this because it can't trunk. So now I've got full connectivity both ways. I mean, I can ping either way, because what happens is it comes in from either one, gets tagged with VLAN 10, then the switch is going to look in its MAC address table, and we'll see that the MAC address for the other host is on the other side. By the way, an ARP request went through here, so you didn't see that, but it went through. And then it'll come across this trunk tagged. The switch 1 will find out where the destination port is, and once it goes out that port, the tag is removed. So there's no tag out here on this access port, but this trunk port does have the tag associated with it. Now the cool thing here is you'll notice too, that by default, all VLANs are allowed on this, and by default, the native VLAN is 1. Now watch what I can do. I'm inside of this, I'm still in FA01. I'm going to switch port trunk, native VLAN, and I'm going to say 99, and then watch what starts happening. Oh, whoa, look at this. BPDU and inconsistent native VLAN. So what I've done is, do show int trunk. One side believes the native VLAN is 99, the opposite side believes that it is 1, and you will continue to receive error messages because you have that inconsistent until you do the following. Switch port trunk, native VLAN 99, and now you'll see that even on this side, do show int trunk, that native VLAN is 99. You also can do switch port trunk allowed, switch port trunk allowed, and you can set what VLANs are allowed if you want to change the VLANs. Okay, you see here the consistency was restored because the native VLAN matches. So big takeaways here is remember when you add a VLAN that do VLAN 30, name, faculty, dir, you'll still see the, well, you'll see the VLAN.dat there, but if you do now you'll see it because I did that. Show VLAN, you'll see it because I did a Control Z. But now we'll do a config key again and do VLAN 40, name HR, do show VLAN. You'll see the VLAN is not there until you exit config-VLAN, which is a new mode we haven't seen before. Do show VLAN. And now you'll see it's there. Two-step process though. Create the VLAN, put the port into the VLAN. Best thing we can do is create also a VLAN, let's say just 999, and let's say name black hole. All right, and then we're going to do the following. We're going to say, I'm going to exit here, so I got it. Then I'm going to say interface range FA01 through 24, and I'm just going to do this because it's easier, and then I'll put FA06 back. Switch port mode. I'll have to fix access list. Well, I can fix that one too. Let me actually, hold on. Let me change my range. Since 01 is my trunk, I'm going to do 02 to 24. This is doing it for all ports 02 through 24. I'm going to do switch port mode access, switch port access, VLAN 999 shut. Okay. Now, if I do a do show run, guess what you're going to see? All my ports are down. Okay. All of them are in VLAN 999. So they're all sitting out there in that, what I call the black hole VLAN. Do show VLAN. You'll see there's nothing except for gig 102 left in VLAN 1, which that gets people in trouble too. So I'm going to do this int FA0106 switch port access VLAN 20 or 10. No shut. So I brought that back up, so that'll work. And I'm going to do int GI01. Hit up arrow a couple times. And then do this, so I can do it in VLAN 999. And then do the same thing to 02. And then I will have all the ports in a okay. Now I can do a Control V, show VLAN. I have all the ports in a black hole VLAN. So nothing's in VLAN 1, all the ports are in the black hole VLAN. I've created my VLAN, so I put 06 into the correct VLAN, which ensures that pingage is still available. Questions?
Yeah, I'm good.
All right. I love this part. I love VLANs. I have to admit it. I'm a little geeky, but I like this stuff. I think it's pretty cool.
Mm-hmm.
Also, it's one of the things you're really starting to see now how to build your LAN. You know, this is how real LANs work. With VLANs, they're not big layer 2 VLANs anymore, so that's a good thing. But we do have VLANs. Here's your, again, switch port mode trunk. That turns a port into a trunk. Switch port trunk native VLAN sets the native VLAN. And then if you want to, you can do an allowed VLAN list. So the thing that's good about allowed VLANs is you can put on there only the VLANs you're going to allow across the trunks that are in your network. The bad thing is, if you decide to add another VLAN, you have to go touch every switch and tell them what VLANs will be allowed across the trunk. So while it is a security thing, it could be a pain if you don't, if you add and remove VLANs consistently or constantly, which is probably something you won't do, but be aware. If you do have a trunk and you want to set it to a non-trunk, you can do no switch port trunk allowed VLAN, which would set it back to all trunks, or all VLANs allowed, or no switch port trunk native VLAN, which would set it back to VLAN 1 for native. You also can just do switch port mode access, and then the trunk port will no longer be a trunk port, it will be an access port. Now again, what's the definition or the difference between a trunk port and an access port?
Trunk ports allow tagged traffic access is just for a device to access the
Bingo.
VLAN.
Trunk ports carry tagged traffic, access ports do not.
Mm-hmm.
And folks, that's chapter 6. You know, the only thing when we get in over here, issues, many times the issue is you forgot to allow VLANs. Show interface trunk will show you what VLANs are allowed, so that's one. You can have IP addressing issues, that's a very common thing. You've got a VLAN missing, or more common is your students created the VLANs, but they did not put the ports into the correct VLANs, or did not put them into the VLANs. Trunk problems, one side's a trunk, one side's not a trunk. That would mean one side's tagging, one side's not. Mismatched VLAN IDs, differences in allowed VLANs. And that's really about it. I mean, this is really simple stuff when it comes down to troubleshooting, because there's only so many things that can be done on those. Okay. Last but not least is inter-VLAN routing. So we know we've got to be able to route between our VLANs. We've got to be able to get between them. So there's a couple ways we can do it. One is this method, okay, and this method is legacy inter-VLAN routing. And basically we would take a port on the router, keep 00, and we'd put port 01 that's on the switch in VLAN 10, and on 011 in VLAN 10, 02 and 30, and 06 and 30, and the traffic would only be tagged as it's inside of this little switch. The problem here is you would need a port per VLAN on the router, okay? It's not necessarily bad, though, if you got a really small network, because guess what? You are dedicating the bandwidth of this entire link to that VLAN, but it doesn't work very well in a modern network because you normally have too many ports or too many routers, too many VLANs for the number of router ports. So we're going to use a router on a stick. And again, this is legacy inter-VLAN routing where you have a single port per VLAN. Kind of crazy. Router on a stick's what we do now, and basically you create a trunk link between the switch and the router, and then you create sub-interfaces that are tagged by the router for each one of the correct VLANs. And so a sub-interface is a physical interface that's been virtually broken into multiple different interfaces, i.e. sub-interfaces, and then they're being tagged with traffic. And that means that if you're going from 1021 to 2022, it would actually go all the way from up to S2, be tagged as being part of VLAN 10, cross across, go up to S1, go to R1, come in. R1 would then figure out that that needs to go to VLAN 20, re-tag the traffic, send it back out the trunk port all the way back down until it goes to 20.22. So the negative here is you've got one physical link servicing multiple VLAN traffic. The positive is you only need one physical link to service multiple VLAN traffic. Now, how easy is inter-VLAN legacy? You just put 2 ports in the different VLANs, and you don't have to do anything at all on the router. The router is configured just like normal with IP addresses and nothing else. You don't have to do anything funky, okay? So again, you just make sure each one of these ports are in the correct VLANs. The router just has IP addresses and no shut command on it. And then as long as it's set up to do IP routing, which it should be by default, it will route between these 2 different interfaces. You notice nothing is configured differently really on the router at all. This is all done on the switch. Now, for inter-VLAN routing on I'm going to go to router on a stick, it is a little different because you do have to create your VLANs and put the ports into it. This is actually an incorrect picture here. They're going to use just one. Instead of using both links, they're just going to use one. They just still got them both connected. So they're going to use this one link that's a trunk, and they're going to assign each sub-interface to a VLAN. The individual ports are also configured to a VLAN on the switch. So let's watch this. This is pretty cool. You go to the physical interface, you go interface gig 00.10. That creates the sub-IF. You'll see the sub-interface. Encapsulation.1Q, so we're telling it to do 8021Q tagging and tag all traffic as VLAN 10. Then you put the IP address on that particular interface. In interface gig00.30, encapsulation.1Q 30. So that information is tagged with 30 and it's expecting the 30 tag. And then do a no shutdown command on the physical interface. And at that point, you will now be routing all traffic across this one link. So PC1 is configured with the correct default gateway, and it wants to ping PC3. That will come in, get tagged as part of VLAN 10, go up the trunk link. R1 will see it's part of VLAN 10, so it will be serviced by the 10.1 subinterface, which is the one with 10.1 on it, which is gig00.10. Make a routing decision, send it right back out the same interface to go down to PC3. Does this make sense?
Yes.
Yeah.
Okay. Really cool. Nothing to it. The last type of thing we're going to look at is switch virtual interfaces. So there are things you can do with a switch virtual interface. I don't even think they show you much. They just show you, where was that at? I know there's one picture somewhere. I didn't even show it. But there's a lab where they're showing switch virtual interfaces where you basically are doing the same type of routing inside the inside a layer 3 switch. So nothing big there. Any questions on chapter 3 or chapter 6? Good Lord, where did I get chapter 3? Chapter 6. We get to have fun with chapter 7 next time, so I'm gonna go ahead and stop. Go ahead, got it, Corey.
No, it's pretty straightforward.
Okay, I'm gonna stop the recording.